Welcome students to the MOOCs course on fuzzy sets, arithmetic and logic. This is lecture number 23 and we know that we are working on fuzzy logic. The basic task is to assign truth values to a fuzzy proposition. Consider for example, the statement is it is raining. Under propositional logic, it may have truth values 0 or 1 and T s is equal to 1 covers all situations from drizzling to heavy downpour, say heavy rains. But practically that creates problem in decision making. For example, drizzle may imply no umbrella to be taken. Medium rain, one can think of carrying umbrella. And heavy rain may imply that one will carry waterproof. Thus, simple truth value assignment T s is equal to 1 does not help in making the decision. In a similar way, consider truth value is equal to 1 for a statement he is having fever. But a doctor's prescription will change depending upon the actual temperature. Say 100° Fahrenheit may mean only paracetamol, but 104° Fahrenheit may mean say head bath. Thus, what I wanted to emphasize on is that simple 0, 1 truth values do not help us in making a decision in real life situation. Hence, we need to expand the scope of propositional logic. And we have seen the following: propositional logic. We have expanded it to take care of multi-valued logic. And another way of expansion was through first order predicate logic, and together we got that we will use in fuzzy logic. First order predicate logic gives us the concept of quantifier and also the concept of variables. And multi-valued logic allows us to use truth values in the entire interval 0 to 1. In today's lecture, I shall focus on this aspect. Now, if we examine carefully the concept of multi-values, come from use of adjective or adverbial modifiers. For example, tall, we can get very tall, we may get rather tall, we may get fairly tall. Similarly, from rain we can get heavy rain, light rain, passing rain. So, these are the terms very, rather, fairly, heavy, passing, light. These are the terms that actually affect the truth values of a fuzzy proposition. such terms which affect the truth values of a fuzzy proposition are called linguistic hedges. In practice, there may be a large set of hedges, linguistic hedges, such as more or less, fairly, extremely. It is not possible to assign exact truth values in the event of altering the truth values for a proposition. For example, what is the difference between very, very and extremely? What is the difference between fairly and more or less? We cannot specify their exact significance. Hence, what we try to classify them into different groups. In general, linguistic hedges are classified into three groups. What are they? One is concentration, one is dilation, and other is intensification. So, let us discuss this one by one. Say concentration. These hedges tend to reduce the membership values for all those members who belong to the set partially. That means, if the membership is 0 or the membership is 1, then their membership values are not altered by these hedges, but for all other their values are reduced to the new class. Say for example, say tall to say very tall. For illustration, let us take this example. Suppose we define tallness as follows. Mu tall of x is equal to 0 if x less than equal to 5 feet 2 inches, it is 1 if x is greater than equal to 6 feet, and in between the membership is x minus 5 feet 2 divided by 6 feet. Therefore, what is going to happen? For each increment of 1 inch in height, mu tall of x increases by 0.1. So, let us plot it. Suppose this is 5 feet 2, 5 feet 5, 5 feet 8 and this is 6 feet. Therefore, at 5 feet 7 inches, the membership is going to be half. So, let us consider this to be half. And therefore, we get following straight line as the membership to the fuzzy set tall. Question is, what is very tall? Now, it is clear that anybody who is below 5.2 will have membership 0, and by the definition of concentrator, anybody above 6 feet will also have membership 1. In between, obviously, if somebody's membership is given here, we expect that membership to the set very tall will be slightly less. So, suppose we draw the membership to very tall by using this curve. And it is clear from the graph that for any height x, if this is the membership to tall, the membership to very tall is this, that is this is mu x of very tall, whereas this is mu tall of x. We can go even further. Suppose we want to give the membership to the set very, very tall. So, how it will look like? So, we will concentrate very tall further, and we can expect a shape like this, which will give us the membership for very, very tall. Thus, very acts as a concentrator for fuzzy membership. In a similar way, dilation, the hedges belonging to this class tend to increase the membership values for those members who are or whose membership are only partial. Example, consider temperature. And suppose we are looking at hot. So, suppose below 20 degree it is 0, at 25 degree it is 0.2, at 30 degree it is 0.4, at 35 degree it is 0.7, at 40 degree it is 0.9, and suppose at 45 degree it is 1. Thus, this is the membership value for hot. Then what happens to rather hot? We expect that membership of these temperatures to the set rather hot is going to be little bit more than hot. Therefore, we may expect something like this. So, that is going to give us membership to rather hot, and as we have discussed some time back, the membership to very hot should go like this. So, this is going to be very hot. I hope the distinction is clear. Question is, how to achieve this mathematically? Typically, concentration is achieved through raising the power of mu a x, where x is the element, a is the set, to mu a x to the power say p, where p is greater than 1. Thus, if mu a x is equal to 0.8, mu h a of x is equal to 0.64, taking p is equal to 2, where h is a linguistic hedge implying concentration. In fact, Professor Zadeh suggested p is equal to 2 for very. Thus, if mu tall of 5 feet 5 inches is equal to 0.2, then mu very tall of 5 feet 5 inches is equal to 0.04. On the other hand, if mu tall of 5 feet 9 inches is equal to 0.8, then mu very tall of 5 feet 9 inches is equal to 0.64. In a similar way, mu very tall of 5 feet 9 inches is equal to 0.64 square is equal to say roughly say 0.4. In practice, one may assign other values of p e.g. say 2.5, 3, 1.5 to take care of different concentrators. In a similar way, dilation is achieved by taking p less than 1. For example, suggested value of p for fairly is half. That is, if mu a of x is equal to alpha, then mu fairly a of x is equal to square root of alpha. Thus, if mu hot of say temperature 32 degree is equal to 0.64, then mu fairly hot for 32 degrees is going to be 0.8. For practical use, depending upon the domain, and its requirements, one may consider p is equal to say 0.75 or 0.8 etcetera to take care of hedges such as rather, more or less, etcetera. A third type of linguistic hedge are intensifiers. Typically, an intensifier reduces the membership value if it is less than half and it increases the membership value if it is greater than half. Suppose we have a membership value, let us consider it to be linear like this between 0 to 1, and this is the value of half, then an intensifier will assign truth values like this. So, mu a of x is less than half, therefore, it reduces them. In this region, mu a x is greater than half. So, it increases them. One possible intensifier is intensify alpha is equal to 2 times mu a x square when 0 less than equal to mu a x less than equal to 0.5, and it is 1 minus 1 minus mu a x whole square into 2 for 0.5 less than equal to alpha less than equal to 1, or you can say mu a of x. Thus, if mu a x is equal to 0.3, then intensify a in this set, the membership of x is going to be 2 into 0.3 square is equal to 0.18. But if mu a x is equal to 0.8, then mu intensify a of x is going to be 1 minus 2 times 1 minus 0.8 whole square is equal to 1 minus 2 into 0.2 whole square is equal to 1 minus 2 into 0.04 is equal to 0.92. Note that an intensifier does not alter the truth values for full membership that is mu A x is equal to 1 and null membership that is mu A x is equal to 0. For mu A x is equal to half, what will happen? 2 into half square is equal to half and 1 minus 2 into 1 minus half square is also half. Thus, if membership is half, it is not altered by an intensifier. Typically, all such modifiers satisfy the following: we use a function h of alpha to effect the use of the linguistic hedge. Say h, the function h satisfies the following: h of 0 is equal to 0, h of 1 is equal to 1, h is a continuous function, in practice we often use a combination of hedges. For example, suppose for tall we use the following: 0 for 5 feet 2 inches, 0.2 for 5 feet 3 inches, 0.4 for 5 feet 5 inches, 0.7 for 5 feet 7 inches plus 0.9 for 5 feet 9 inches and 1 for 5 feet 10 inches. So, suppose this is the membership values we assign to the class tall for different heights. Therefore, short and suppose short is defined as 1 for 5 feet 2 inches, 0.9 for 5 feet 3 inches plus 0.7 for 5 feet 5 inches plus 0.4 for 5 feet 7 inches plus 0.2 for 5 feet 9 inches and 0 for 5 feet 10 inches. Suppose these are the two fuzzy sets defined on the subset of heights. Therefore, very tall is going to be, by making alpha going to alpha square, we are having 0 for 5 feet 2 inches plus 0.04 for 5 feet 3 inches plus 0.16 for 5 feet 5 inches plus 0.49 for 5 feet 7 inches plus 0.81 for 5 feet 9 inches plus 1 for 5 feet 10 inches. And not short by using 1 minus alpha, we get not short is equal to 0 for 5 feet 2 inches plus 0.1 for 5 feet 3 inches plus 0.3 for 5 feet 7 inches plus 5 feet 5 inches plus 0.6 for 5 feet 7 inches plus 0.8 for 5 feet 9 inches and 1 for 5 feet 10 inches. And suppose we are looking for not short and not very tall. We want to find membership of, say, boys to this set. So, in order to do that, we first need to compute not very tall, and that set is going to be by again taking 1 minus alpha and applying it on very tall. We are getting 1 for 5 feet 2 inches plus 0.96 for 5 feet 3 inches plus 0.84 for 5 feet 5 inches plus 0.51 for 5 feet 7 inches plus 0.19 for 5 feet 9 inches plus 0 for 5 feet 10 inches. Therefore, not short and not very tall, say, membership to this set for an individual x, we can compute by taking the minimum of mu not short and mu not very tall for x, and that is going to be in this case 0, 5 feet 2 inches plus 0.1, 5 feet 3 inches plus 0.3 for 5 feet 5 inches plus 0.51 for 5 feet 7 inches plus 0.19 for 5 feet 9 inches plus 0 for 5 feet 10 inches. So, in this way we can use a combination of linguistic hedges, and from there by using the formulae that we learned already, we can compute the membership values for different x belonging to the set by combining them suitably. However, we have to be careful in using combinations. For example, what is not very tall? Is it not of very tall, or is it not very, and that together is a modifier to tall? This is a linguistic question, and perhaps an answer is not very clear. In the example earlier, I have used this definition. Also, some combinations may be meaningless, say for example, fairly very hot. More or less rather tall. Such combinations may not really have any meaning, but by using formulae we may be able to compute their values, the membership values for different entities, but its practical significance is very doubtful. Some other problems one is that the same sentence may be expressed in different ways, e.g., John is tall, John is a tall boy, John has a good height, all may mean the same thing. Therefore, we need canonical form. Another problem, the propositions may be qualified or unqualified. Say John is tall is unqualified, but John is tall is true, is qualified. Similarly, John is very tall is true, and other is John is tall is very true. Both are qualified, but do they have the same meaning? We need to understand how to deal with such propositions. Before I stop, I give you one more point. When we say John is tall, it appears the membership defined on the name John. But actually, tall is defined on measure of height. Similarly, today is hot is not defined on the date of today. Here it is defined on the temperature prevailing today. So, when we talk about fuzzy propositions, we need to take care of these as well. Okay, friends, I stop here today. In the next class, I shall discuss different fuzzy propositions and means of handling them to obtain their truth values. Thank you.